All right. Federal Railroad Administration Track Rail Infrastructure Integrity Compliance Manual Volume 2 Track Safety Standards Chapter 1 Track Safety Standards Class 1 through 5. Alright, 213-121 rail joints. 121, A. Each rail is insulated with a joint compromise shell to be structurally sound and design dimension on the rail, for the rail which is applied. Again, for the proper railroad transfer, the curve of the railroad must contact with the head of the base of the railroad with the bolt and the top of the varying with the rail joints that have been assigned with the varying degree of success. And the track safety standard does not attempt to single out any of the particular design as one only acceptable joint. This could be inhibit the innovation with the modern track design. The track safety standard requires structural soundness. Bolt condition makes based on maximum authorized train speed. The inspector must be attentive to the location where standard joint bars are used. The joint dissimilar with the rail section, whether they would be proper to have the compromising bar. The track safety standards recognize that the important aspect of the rail joint begins with the section with the requirement that the rail joint has structurally sound design dimension for the rail on which they have applied. Rail joints are considered necessary discontinuity with the requirement of special attention for the railroad, maintenance personnel of the railroad, inspector of the FRA, inspectors as possible. Railroad should provide with the relevant strength and stiffness, flexibility, and uniformity as the rail itself. The following figure illustrates the proper application of compromising joint bars. Alright, your left hand out, left hand out, right hand out, the face of the joint and between the rails determine the gauge. The left hand gauge at 140 RE, Reading rail, right hand gauge. Base between the rails and determining the hand, 11-115 RE rail. As shown in the following figure, one of the design elements of the joint bar would be considered if it is a head contact headed free of the design, the head contour bar with the rail end with the box type construction carrying with the load between the underside of the head of the base of the rail. The head free joint bar does not contact with the underside of the rail heads, but instead of the contact with the rail in the fillet, the load distribution is referred to the triangular load distribution. The box type load distribution, head on contact, triangular load distribution, head contact and head free. The usage standard for the joint bar for the head contact design with the rail section of the design may be constituted with the deviation difference between the head contact joint bar and the head free joint bar are significant. An evident joint bar with the rail design does not bend flexibility, flexes exactly with the other along with the length of the test measurement show. Is the positive bend existing downward being pressure for the underside of the head of the rail with the top of the surface of the joint bar. Some of the distance along with the bar of the way the rail ends, approximately 2 inches. There's along an upward bearing pressure for the upper surface of the base of the railway apart with the length of the bar further away at the railway end, bearing distance approximately 3 inches for the converse true with a negative bend. The head-free joint bar accepts the bearing with the shear force with the vertical load of the rail upper filled with the head of the contact bar. It is not designed to fit into the fillet specifically. The head contact joint bar accepts the bearing with the vertical load of the underside of the rail head, but generally on a 1-to-4 slope that is not designed to seat on the railroad upper fillet. Although the vertical fishing dimension of the 112 and the 115 RE rail section identical with 3 and 3/16 of an inch of head fillet radius is different. For a 115-pound rail section, railroad acquires 3/4 of an inch. For a 112-pound section, railroad acquires 3/8 of an inch. As shown in the following figure, the 115-pound head free bar fits with a 112-pound rail fillet practically at a point, most probably inducing the joint bar stress in excess of the design deviation of the statute 213-121A. The 112-pound head contact bar does not properly fit with the 115 rail fillet bears the very small areas beneath the bed of the rail, possibly inducing joint bar stress. Excessive design exerting wet action between the rail of the head real web promoting the head of web separation addition with the joint bar may experience a test from the torsional force and the tightening of the track bolts when used for the compromise between a 115 and 112-pound rail. The torsional stress from the twist of the grade is at the head of the toe of the bar of the rail ends. For your 115-pound head-free joint bar, rail, and contact stress areas, I have 3/8 of an inch and 112 head contact joint bar, 115-pound rail. There are exceptions to be used for the joint bar head contact design with the rail section other than design. For example, the 131-pound and 132-pound head contact joint bar may be used in lieu of the 134 and 132 or 131 through 100 and 136 compromising joint bar rail drilling, joint bar punching, It is the same width of the railhead is in these configurations sufficient to allow the full contact of the upper fishing wear surface. So in summary, the 112-pound rail joint bar should not be compromised with the joint bars with the 112 rail and 115-pound rail. 115-pound rail joint bar should not be used with the compromising joint bale with the 112 and 115 rail bar. 131 rail head contact bars and 132 head contact bars may be used with the compromising joint bars, and the 131 and 132 rail with the 136 rail when the rail drilling and the joint bar punching are the same. Note that the upright does not prohibit the track owner from field drilling bolt holes to fit. While the above address compromise the joint bar to strike with the 112 bar rail bar not being used, the 115 and 119 pound rail vice versa joint bar, 131 rail head free and the 132 head free design, 131 head free and 136 head free joint bars are not interchangeable or not to be intermixed. For componium, for the rail section dimension, in order to compare with the rail section compatible between the joint bars of the various rail sections, see refer to Appendix C of this manual. 121B, but if the joint bar of class for 3 and 5 track is cracked, broken because of the wear allows successful vertical movement of the rail and all the bolts are tight, it should be replaced. Guidance: if the joint bars are designed to fit with the space between the bottom of the railhead, rail-based fishing, while the bolts are tight with the rail bars of wedged with the fishing place space to provide lateral vertical beam strength supporting the abutting rail ends. When they head against the rail bolts and the joint bars are connected with the rail, they have 2 points at the bottom of the rail head and fillet, top of the rail base with these contact points known as the fishing surface that can be experienced metal loss with abrasion, mechanical wear with the curve during the cyclical training dynamic loading, and any long-term surface of the fishing surface with the rail with the bars and wear with the point with the jointed bars not wedging in the into the rail when the type of the bolts in such a case with the joint assembly is no longer optimal support with the butting rail ends. Alright, joints minimal with worn fishing surfaces can be provided with the safe patches with wheels class 1 through 5. It's guided with the excessive vertical movement would exist. There is a significant fishing surface wear of wheels loaded with could be abutting the ends with exhibiting tread mix matching appropriate thresholds of the 213 115 for excessive vertical movement. Because there are cracks in correction, action would be replaced with the bars and take other corrective action. Proper corrective action with the joint bar cracked or broken other than center bar with the class for 3 and 5 track would be replaced with the reduction of class 2, but both joint bars are cracked broken between first and second bolt hole, including the second bolt hole. It should be considered class 1. This because of the only one bolt in the rail end is within the remaining section of the joint bar to provide it with the support. 121C. If the joint bar is cracked or broken with the middle of the 2 bolts, it should be replaced. For a son of the crack of the broken bar, appropriate for the corrective action would be replacement of the reduction class 1 speed under provision statute 213.9b. 121D. In case of the conventional joint track, each of the rails should be bolted with at least 2 bolts for the joint class 2 through 5 track, at least 1 bolt hole in class track 1. The track owner must have the number of required bolts in each rail with the joint, with the paragraph does not prescribe the tough tightness of the torque should standard for each of the bolt, but no longer can support the joint bar against the rail, continue to provide a resistance for the pull parts when the rail is in tension. The ability for the bolts to hold against the rail, support the abutting rail ends, and covered under statute 213.121F. As the bolt does not fill with the requirement of the paragraph, the admitment the danger of complete the failure is no longer the holding of the bar to the rail and no longer resist the pull apart. For example, the nutting is missing, that it will likely fall apart with the subsequent train movements of the bolt shaft is fractured. 121E, with the continuous welded rail track of each of the rail bolted with at least 2 bolts at each of the joint guidance railway and rail installed with the continuous welded rail remains the continuous welded rail guarded with whether the joint or plug installed with a later time. If there's only one bar with the rail and jointed with the continuous welded string with one of the bolt will be subject to the tensile axle forces that easily shear and break, resulting in a pull apart. 121F. Each of the joint bars shall be held in position by the track bolt tightened to allow the joint bar firmly support the butting rail ends to allow the longitudinal movement of the rail joint to accommodate the expansion contraction due to the temperature variation. When no slump of the joint of the rail and contact exists in the design requirements of the paragraph do not apply. The location over the 400 feet length, considering to be continuous welded rail track, shall meet with the requirements of the continuous welded rail track prescribed in this part. And the joint bar is loose if the joint is compliant with the statute 213.121F. In addition, with the joint assembly compliant with the adequately tightened bolts to prevent supporting the butting rail ends under the expected traffic loads. Joint bolts are deteriorating sufficiently to create condition with the bars and may become completely detached with the rail cut with the total lack of support will contribute to a broken rail. Such condition can create a mismatch with exceeding limits specified in statute 213-115A. 115 rail end mismatch. In such case, the defects with the rail mismatch and class specifically the inspector should also include the notation about the loose joint bars. This paragraph also recognizes the design characteristics enable the rail end of the joint to move longitudinally, hold the handle with the temperature change with the expansion contraction rail creep the track flow, the type of the joint bars assembly with the same of the joint rail because of the type of the track construction and lower axle forces then continues while the rail is desirable to contain a rail expansion contraction with the remaining joints and insulated joints in order to eliminate pull apart action that occurs with the regular joints and continues while the track structure is designed to dissipate x-axle forces. According to the paragraph allows the joint design to stop with the regular rail movement with the assembly. Expect for the axle movement the component of the paragraph joint bars to be glued with the installed with the object of all the remaining requirements of the paragraph all other than statute 213-121 the type of the assembly is construed there to be joints even if the continuous weld of the rail statute 213-119 however the definition of which the continuous weld of the rail the glued joint is not longitudinal discontinuity of the rail string the glued joints are considered joints under the statute 213-109 respect the required position of the non-defective ties at the joint. 121G no rail shall be have the bolt hole with the torch cut with a burn with a class 2 or 3 2 through 5 track. Alright, again, the paragraph prohibits the use of the containing with a bolt hole that has been torch or cut or burned class 2 through 5 track. 121H, no joint bar shall be reconfigured by torch cutting in class 3 through 5 track. The paragraph prohibits the reconfiguration of the joint bars torch cutting in class 3 through 5 track with the omission of reference to class 1 and 2 track. This practical configuration is allowed for the needs in those classes where the joint bars are reconfigured by torch cutting must meet certain criteria for the structural soundness for the design dimension, which is required under A of this section. Alright, 213-122 torch cut rails. 122A. Except for the temporary rail in emergency situation, no rail have cutting torch cut and shall have the class 3 or 5 track rail and if this torch emergency situation train speed over the rail shall not exceed the maximum allowable of class 2 track. For existing torch cut rail and for the class 3 through 5 track will also the following shall apply. Within 1 year of the September 21st, 1998, all torch cut rail and for the class 5 track shall be removed. Within 2 years of the September 21st, 1998, all torch cut rail and class of the class 4 track shall be removed. And with 1 year of the September 21st, 1998, all torch cut rail and for the class 3 track over which the regularly scheduled passenger trains operate shall be inventoried by the track owner. The regulation prohibits the torch cutting of the rail end for the class 3 through 5 track except for the temporary rail with the emergency situations. Emergency situation, the train speed shall not exceed the maximum allowable class 2 track exhibit. Existing torch cuts must be removed for the track for the following time frames. Class 5 track, September 21st, 1999. Class 4 track, September 21st, 2000. Class 3 track with passenger, September 21st, 1998. All torch cut shall be inventoried by the track owner. 122B. The following expiration time limits specified in A1, 2, and 3 of the section. Any of the torch cut not removed with the Class 4 and 5 track. Any torch with the cut rail not inventoried in Class 3 track over the regularly scheduled passenger train operating shall be removed within 30 days of the discovery. The train speed over the rail end shall not exceed the maximum allowable Class 2 track until removed. The torch cuts inventoried will be grandfathered in. Any torch cuts found with after the expiration of the year, 1 year not inventoried must be slow ordered in the Class 2 speed with removed within 30 days of the discovery. Railroad choose upgrade with the segment track Class 3, the passenger train operated with all torch cuts must be removed before the speed of the exceeding maximum of the Class 2 track with the railroad choose. The upgrade with the segment of the track lower class with the Class 4 and 5 must remove all torch cuts. Our 213-123 tie plates in 123A in class 3 through 5 track with the timber cross ties in use. There must be tie plates under the running rails at least 8 or 10 consecutive ties. In 123. B. In class 3 through 5 track, no metal object with cause concentrated load solely supporting the rail should be allowed between the base of the rail bearing surface of the tie and paragraph B of the applicable September 21st, 1999. Guidance inspection should consider the section jointly requirements of the cross-tie rail fastening report tie plate condition of the effects of the safety impaired with the base absence of the tie plate. Class 3 of the 5 track, no metal object covered with the concentrated load solely with support of the rail should be allowed between the base of the rail between the surface of the tie plate with specific reference to metal objects intended to include with those items of the track material that pose greatest potential broken base rails such as track spikes, rails, or anchors, shoulder of the tie plates and freights that could also concentrated loaded solely supporting on the rail further further clarifies the intent of the regulation to apply only in the instances where the clear physical evidence for the metal object is placing substantial load on the rail base as indicated with the loading on adjacent ties. 213.127 Rail Fastening System. A. Track shall be fastened with the system components effectively maintains the gauge within the limits prescribed in Statute 213.53b, with each of the component of each of the such systems shall be evaluated to determine whether the gauge is effectively maintained. Guidance. Rail fastening system include modern-day elastic fastening system, which consists of the abrasion pads, the insulator clips, and shoulder inserts for the casting and the concrete ties, as well as the fastener itself, which may be different designs in use today. The fastening system can also be the traditional cut and spike variety, with or without tie plates. Failure to concern with the critical components of the particular system could adversely affect the ability of the individual fastener to provide with adequate gauge resistance. The wording of the regulation provides with the evaluation components for the system necessary for the integration of the fastening system as resultant programs problems maintaining the gauge but the limits prescribed in Statute 213.53. When the inspector identifies the gauge of the geometry condition for the fastener system as graded location in question meets the factory described below, the inspector must examine the component of the fastener, e.g. for the clip and installation, bad, bolt, spiking, pattern, etc. The inspector should describe the nature of the field components on the field Form 6180.96 of the fastener condition form cause of the gauge exceeding the limit to Statute 213.53. Inspector shall report the condition with the gauge defect, describe the nature of the fastener condition with the same defective line of the report. The section requires the inspector to exercise the judgment evaluation condition. The fastener of the following factors should be considered in evaluation. Gauge exceeding the limits of Statute 213.53. Such gauge and tracks the class will govern. Gauge closest to the limits of 213.53 at evidence of recent widening of evidence of recent rapid deterioration. Gauge with probable condition of deterioration. Evidence of recent significant damage to the rail fastener extent with the gauge with the widening is probable. Evidence of recent maintenance work improperly performed resulting in a lack of sufficient fastener to prevent the gauge of widening under the expected traffic condition, including speed, tonnage, and type of equipment condition, the curvature and a grade. However, inspectors may use the PTLF or the described in Statute 213.110 for the purpose of measuring the effect of the fastener, but the refer to Appendix D for the portable track laying, loading for the fixture instruction for the non-geometrical gauge railroad measurement territories. I'm not sure what it means. I forgot. It's been a week since I read this. I don't really remember the back. A unique attributed with the concrete type of abrasion can occur with the base of the rail seat with the cross-tie component of the rail fastening system with the variety of the pad design material placed between the rail and the tie integrated with the abrasion. However, the unequal wedge abrasion with the rail seat can be problematic with a high-speed, high-tonnage operating environment may cause the rail fastener to become loose and under the load, extremely cause the cutout of the rail tilt or rolled out. So see the following figure. According to the inspector, should look with the rail rollout due to the rail seat abrasion concrete cross ties, particularly in territory with a heavy traffic levels, moderate curvature. The mechanics of the condition concrete cross ties include the following elements. Starting with rail seat abrasion and then heading left, the resilient fasteners, lateral forces, and then clockwise vertical forces roll out, resulting force on the concrete cross ties. Concrete wear and abrasion resulting in loose rail clips, insulator pads, loose components with always more moisture abrasive than the inner rail seat. Once the field set with the rail base wear for the tie plate with the contact with the concrete tail rail seat with rapid cutting with the concrete, accelerated abrasion can occur. Signs and symptoms of the concrete cross-tie rail seat abrasions include the tie pad crushed and squeezed, maintaining the integrity of the tie pad essentially. Insulator crushed, moving or missing, clips loose or indicating the pressure of the rail base, loss of the toe load. Longitudinal rail movement indicates with the cement color paste instability from a braided rail seat. Metal flaking, grease streaks in the center of the low rail with the curve caused with the outer of the rim of the wheel with the falls flange, placing excessive pressure on the heel of the head of the rail with the condition generally created with the gauge widening. Based on the above decision, the apparent rail seat abrasion with the concrete ties causes the rail rollout. The rail rollout decreases the effectiveness of the rail fastener and will often leave with the gauge geometry condition. The general rule: inspectors should cite with the condition of the rail fastener defect code 213 code 0127A. However, the rail rollout caused the gauge exceeding the threshold of the design class track of the track. Inspectors should cite the condition of the gauge defect in Statute 213.53. Rail anchors are not considered to be rail fasteners. In the area of the rail anchors are used in combination with resilient fasteners. Concrete ties resilient rail fasteners are normally performed in dual function restraint. Laterally longitudinal should only be evaluated with the ability to provide lateral resistance to prevent gauge widening regarding this section. Insufficient fastener defects should be written when unsafe conditions result from missing defective fasteners, e.g. head of the cut spikes was sheared off at the throat and otherwise supportive cross ties. B. If the rail anchors are applied to the concrete cross ties, the combination of the cross ties and the fasteners and rail anchors must be provided equivalently effectively longitudinal restraint. The paragraph requires the rail anchors to be applied with the concrete cross ties, and in combination with the cross ties, fastener and rail anchors must provide effective longitudinal restraint. Effective longitudinal restraint is performance-based standards. C. Whenever the transfer replacement impaids for installation insulated joints, but the performing is intended, but the fastener may be modified, removed, and provided with the cross ties support rail. Guidance addressing instances fasteners replacement impeds for the insulated joints performing the intended but the permit. The fastener may be removed, provided with the cross tie support. With the support means with the cross tie in direct contact with the rail, leave the incidental space between the tie and the rail. Certain joint configurations do not permit the conventional fasteners or fit properly, with the result of the manufacturer often modified fit along the rail with so long as the provided with the fastener provided with the longitudinal requirement, or it is made comply providing lateral restraint and accomplished with ensuring full contact with the rail and additional placement anchor base for the rail. Additional FRA notes that the requirement of having an effective cross tie within the period of description, prescribed distance of joint with the statute 213-109E would apply with the modification insulated rail. The FRA has mandated the type of equipment with the manufacturer of the track owner must use the incentive to determine and regulate with the performance of material of the minimum safety standards promulgated in statute Part 213. Alright, 213-133, turnouts and track crossing generally. 133, A. Turnouts at the track crossing of the passing must be intact but maintained so they keep the combat secure in place. Also, each switch and frog of the guardrail must be kept free of obstruction that may interfere with the passage of the wheel. The rules specified for the components of the fastening should intact and maintain secure place. The several types of the fastening shall include reinforcing strap of the connection rod, rail hold-on clamps, braces for more extensive with the compilation of the fastening. Such fasteners located in the defect codes 213-133 when the fastening loose of the missing of the inspector should be cited with the railroad of the statute 213 defective code 0133 A15 turnout or track crossing fastening not intact to maintain addition with the fastener loose of the missing that's an apparent contributing condition a large section with the casting of the broken out with the add and grade rail crossing. Inspector should include the description of the contribution condition of their inspection report. 133B. The class of 3 through 5 should be equipped with the rail anchored ran through on each of the track crossing turnout to restrain the movement of the effective of the position of the switch points of the frog class 3 track of the paragraph of the effective of September 21st, 1999, and 113C with each of the flame with the turnouts and track crossings must be at least 1 1/2 inches wide. Or turnout of the track arrangement consisting of the switch and frog extending from the point of the switch of the heel of the frog of the arrangement to allow for the engine of the cars to pass from the one track to another, passing the operating movable parts of the lateral thrust, essential for the passing to be placed in the tight of the sound condition. A track crossing diamond is assembly used with the two tracks is intersecting grade, permitting with the traffic on either crossing of the rail with the other, and consisting of the 4 frogs contained with the short rail with the plant manufactured diamond. Because of the impact of the construction crossing subject is essential for the passing to be placed with the tight and sound condition, each switch and frog guardrail must be kept free of obstruction. Anchors on each of the turnout with the crossing throughout the turnout was required with the Class 4 through 5 track. Class 3 track requirements effective September 21st, 1999. Determine the adequacy, accuracy on each of the turnout and crossing through the terminal. Inspector should determine the capable of these devices. Restraint, rail, assure proper fit and switch points, prevent line integrity and irregularities. Ties and timbers, switch and crossings must be sound condition, well tapped, and road bed must be adequately drained. Flange of the turnout track crossing must be at least 1 1/2 inches wide. Turnout and track crossings must be walked and measurement made that they can be included with the ad form 6180.96 form used in the unit inspected. Alright, 213-135 switches. 135A. Each stock rail must be securely seated with the switch plate must be carefully should be used to avoid the canting of the rail over tightening the rail braces. The track safety standards in statute 213-135 specify the requirements of the switch restraint with movement and fit with each stock for the rail must be securely seated with the switch plate. Various conditions, the loose braces, the hanging ties can cause stock rail to become unseated. With the situation, inspector should cite the railroad in statute 213 defective code 0135A1. Alternatively, the stock rail can become unseated with the braces over tightened during the maintenance. In the situation, inspector should cite the railroad at 213 defective code 135A2. 135B, switch point shall fit with the stack rail properly with the switch stand either in the clip position allow the wheels to pass with the switch point lateral vertical movement of the stack rail and switch plate and or of the switch plate with the tie not adversely affected with the switch point to the stack rail broken or cracked with which the switch must be subject to the statute 213-113 except with the remedial action C, D, and E are required with the joint bars. Joint bars cannot be placed due to the physical configuration of the switch. Remedial action B will govern taking into account the head and safety provided with the presence of reinforcement of the switch point guidance. The paragraph recognizes the existing of reinforcement bars or straps which with the points of the joint bars cannot be applied with the rail defect for the required in statute 213-113A2 because of the physical configuration of the switch. In this situation, the remedial action B will govern the person designated under statute 213-7A who has at least 1 year of supervisory experience with the track maintenance will limit train speed at not less than exceeding 30 miles an hour maximum allowable speed. Statute 213-9A with the appropriate class for the track, whichever is lower. Of course, the person exercising the option statute 213-5A when appropriate. Section 213-135B with the address of the crack with the switch rail point with the reinforced strap acting with the surrogated joints with the switch point and the rail not correct only a strap the crack with these appropriate site for the statute 213-135B with the inspector should cite with the appropriate defect for the statute 213-133A normal minor cracks in a strap area major concern with the however the strap is fully broken cause other problems loose switch etc. in the statute 213-133 throwouts and tracking crossing generally would be appropriate if the straps and the switch point are both broken and then there is an unprotected rail break and the inspector should cite the appropriate defect under the statute 213-133. Sorry, 213-113. Most industries call for a 4 3/4 inch opening between the switch point with the stack of the rail measured at number 1 switch rod as a component where the least motion. Lost motion will result when the problem elongated with the switch and on the rod holes will encounter with the switch rods may be adjusted with the clip, the adjustable slide, the jaw clamp, the rocker clips, etc. Adjustment may also have been accomplished with switch end depending on the design assembly. In some cases, the loss of motion compensated with additional properly designed shim between the switch assembly and switch rail. When the opening substantial leash of the standard dimension with the wheels can be passing through the switch is intended to have the back of the wheels being contained with the inside of the rail with the opening switch rail with the interaction can be undesirable lateral pressure against the switch rail. The pressure can contribute to the broken heel bolts and cause crack. Broken switch blades broken with the switch crank, cross pins, extreme circumstances of the closed point on or under with the movement because they have transfer lateral rolls through the switch rods. In the circumstances, the inspector should make an extra effort to determine the condition of all the effective components. The amount of the throw is one of the factory. If the amount of the throw is one of many of the factors must be taken into consideration during the railroad compliance to statute 213-133 and 213-135. Based on the above, to make sure the switch points are snugly against the rail and switch of the throw in the either position. As appropriate, request for the railroad representative operate the switch test for the loss of loose connections. The appendix of the American Railway Engineering Maintenance Association portfolio track work plans containing the following split switch terms: split switch with the uniform riser springs, split switch with the switch rails uniform and the elevation rise plates and the length of which for the switch, therefore not having a heel slope. The point rail begins running off the back of the switch of the closure rail. Split switch with the graduated riser, split switch in which the switches are gradually elevated with the graduated riser plate until they reach the required height above the stack rail, but therefore having heel slope. The heel of the switch pin is higher than the stack rail. The heel joined with the uniform riser layout with the graduated layout with the switch point with the same elevation stack rail and the mixture of the uniform rail with the graduated riser plate and the same switch will not especially address the track safety standard for the cause of the undesired stress on the switch rail with the closure with the rail. The inspectors may note the intermixing of the switch plate with the turnouts having the high amount of the traffic. 135C, each of the switch may be maintained so the outer edge of the wheel tread cannot contact with the gauge side of the stack rail. Inspectors examine the seating with the stack rails and switch blades to ensure the outer tread of the wheel cannot engage the gauge side of the switch rail. Grease lines with the slight grooves that are running on the slight angle of the tread of the side can be provided with the inspector's glue of the wheel. Interference with the marks can be found in the area where the wheels transition with the switch of the stack rail will be found with the inspectors closely and examine the gauge side of the stack rail to measure the outer edge of the wheel. Treads not contacting the gauge side of the stack rail is shown in the following figure. The type of the defect that occurred with the worn switch rail. Switch plates remaining in the place after the stack rail has been renewed. The cause of the switch rail to drop from the same level as the corresponding stack rail. The danger associated with the condition is the possibility that the outer edge of the wheel contact the gauge side of the stack rail during a trailing movement through a switch, thereby turning over the stack rail. Alright, this shows your outer edge of the contact, your worn switch rail, and your worn switch plate, and your stock rail. Other items cause outer edge wheel contact, including improper surface of the poor cross-tie condition, loose rail braces, stock rails not securely suited Seated switch valves have priority. Majority of the track used on one side of the turn-on screw joint. The heel blocks in the proper elevation. 113.5D. Each of the heel of each switch. The heel of each switch rail shall be securely with a bolt. Each with the heel shall be kept tight. At least 2 bolts in each of the rail required to ensure the heel of each of the switch rails is secure. Purpose of determining compliance with statute 213.135D. Examine the heel assembly and fastening bars along with the service condition of the heel and proper elevation of the heel assembly, respectively, relative to the stock rail can lead to the outer edge of the wheel contact. Assess vertical movement of the switch point. If the heel joints were considered normal joint, only one bolt per joint rail end would be required for the heel of the Class 1 truck. However, the heel joint function in a different manner than the normal track joint. The heel joint serves as a pivotal point of rotation with the switch point that helps maintain the proper horizontal vertical longitudinal fit on the switch point against the stock rail. 1 bolt per end of the Class 1 track of the heel joint does not provide the redundancy. The loss of the single bolt in the rail end of the heel joint could cause serious safety consequences. Some railroads heel joints may have as many as 6 bolts or higher track classes. Typically, when railroads plan to field weld, they do not drill the middle 2 bolts in the rail of the 6-hole joint bar. The practice which provide at least 2 bolts in the rail end of the heel satisfactorily secures the assembly. Switch heel assembly joint bars are performed with the function of the joint such where the improper joint bars are heel blocked. The inspector should cite the statute 231.121 rail joints. For example, the improper joint bar installation 6-hole joint bar where the 5-hole bar design should be used. There should be deviation to statute 213.121 because of the improper design bar of the application, which made it be difficult to throw the switch. It may cause gapping. 135E, but each switch and connecting rod should be securely fastened and operable with the excessive loss of motion. Guidance for hand-operated switch stands virtually all types of rotary motion imparted with the vertical spindle with the stand of the person operating with a hand lever and translated into the particular linear movement of the connecting rod right angle the combination over the end of the spindle beneath the stand with the attached crank. Unless the cranks are integrated with the spindle with the casting during the manufacture, the separate pieces must be joined with the cranks attached with the spindle in one or 2 ways. 1, they are maybe turned into a thread opening on the side of the spindle. 2, they may be fabricated into have a square rectangular smooth opening at one end, which can be moved below one up on the top of the spindle, having a similar cross-section position, where it can be secured in place for the horizontal and cross-pin with the simultaneously engaged with the cranks with the spindle. Well, for ease of this reference for discussion, first case was referred to as Type A. The second case with Type B and desired decoupling the connection rod with the switch chain can occur. Type A with the bolt and attaching the connecting rod with the thread crank comes out. And Type B, separation of the crank spindle can occur with the absence of the cross-pin. Either the instance could result in gapping the closed switch point under the train movement unless some other device is placed physically in restraint with the points. Type B. Switch stands may at times have a plate arrangement with a sheet metal suspended with the head block timbers beneath. The assembly of the device generally shown in the U-shaped, commonly referred to as a safety plate. The function of the plate is twofold. 1, the restricted downward movement of the crank onto the spindle should cross the pin be absent. The cross does not completely separate the spindle. 2, the vertical unrestrained crank of sliding down the spindle far enough to permit the connection rod enough space below the bottom of the switch stand to move off the lug of the crank, and therefore there have been cases of the cross pins from fractured plate itself deformed so that the downward displacement of the crank was sufficient to enable the connection rod to clear the crank lug for the contacting base of the stand, which leads to the coupling of the switch and the stand and the connection rod. Inspectors must constantly bear in mind with the aspects of the switch chain performance that are critical crucial to functional safety. Discussion concentrates the region of the mechanical linkage between the switch points and the switch stand that may be difficult to observe in the crossover of the turnout inspection. There are several different types of styles. The Type B switch stand that are in use with the main tracks in the yard and the railroad industry. The models in different minor ways. Nevertheless, they rely on cross-pin restraint for the spindle cross and crank area subassembly. They also share the vulnerability to uncoupling switch stands and connecting rods. And turnout inspection must include examination of the hard to see parts even. Inspectors should examine the effectiveness of the fastening system in which the stands result and the head block tied to the log or the signs of the movement of the switch stand, which can result in the loss of motion leading to the gap switch point. Part 135F. Each of the throw levers shall be maintained so that they cannot be operated with the lock or the keeper in place. The inspectors must examine each of the switch, lock, and keeper, the certain type of the switch, and they should be internally toggle with his hands thrown in all which way in each of the position to hold the switch point against the in-stock rail. The type of the switch are used on other than main track and other semi-automatic designs, whether the train trailing for the turnout, which switches incorrect position initial force with the point over. The final throw is completed with the internal toggling action of the switch stand by designing an application preference. These switch stands might not have a cut lock or keeper on the other main track application. See figure follow below. This concern associated with the type of the switch stand retrofitted with the SAPM strap, the bolted welded one with the two flanges with the throw lever to stop the bolt has been proven and effective at preventing the rotation of the strap. Bead welded placed by the manufacturer at the top of the strap, the crack of the repeated depression of the keeper. The strap rotates downwards, alternating location, lock, shackle, and keeper, allowing the throw of the switch lever without removal of the lock and keeper. If above the type of the switch stands are used with the switch and derail but not requiring the securing the soundness of the strap is not in the question. If the track owner requires the stand to be secured with the lock and the keeper, the welds displaying the cracks will call into the question the sounding latch mechanism and 213 defect code 0135F the throw lever potential. Operable switch lock keeper in place should be cited with the recommended violation. If the track owner fails to aggressively address the correction of potential defect on the subject type of the switch stand, consider recommendation violation of chief of counsel. Title 49 CFR 218-105 requires the all-hand operated main track switches are to be locked and an effective one latch aspect can allow the throw lever to be switched where they can be operated with the lock in place. The several different types of on-hand operated switches and use inspector should inspect each of the latching mechanisms for the wear and possible operation with the throw lever lock in place. The inspection should include stepping on the latch with the observation clearance between the throw lever and the opening of the radio when the latch is depressed and locked in place. Inspector should not attempt to raise the operating lever request of the accompanying railroad representative to lift the hand of the operation through the latch if probable. If it's safe to do so, as shown in figure below, the throw lever is clearly operable and locked in place. Many power switches are operable, either power and remotely control operated with the train dispatched by hand, or frequently called the dual control switches. Inspection of the type of the switch machine is similar to typical hand operated switch stands. Most of them have two levers on one move the switch machine to the power operation, one that acts as the throw lever. The latches should be inspected with the possibility of the power lever and throw lever being operated with a lock pin. Please see the following figures. Alright, this shows your throw switch latch. 135. Each switch position indicator should be clearly visible at all times. Examine the condition of the switch position indicator. Note that any of the unnecessary obstructions visibility requirements is not mandatory. That every switch have a position indicator merely requires that such device is clearly visible when installed on the switch stand. 135H. Unusually chipped or worn switch points shall be repaired and replaced. Metal flow shall be removed to ensure the proper closure. Guidance. The rule does not provide with the specific dimensions of determining the switch with the points unusual chipped or worn. The accident incidence and old base that includes the worn and the broken switch point are the largest single cause of the derailments for the general category of frog switches and implements. However, the most of the derailments are retained also on the casual factors such as the wheel flange condition, truck stiffness, and train handling characteristics. Therefore, qualified individuals must use their experience to determine whether the switch point is unusual chipped or worn. 135I. Tongue and plane mate switches, which is designed and expected in Class 1 track and expected in Class minimum age limits and permitted in Class 1 and accepted track. The paragraph provides exemption for this item of the specified track work with the primarily use of the pavement of the street roads, which was designed with design conform with the maximum gauge limit as prescribed in Class 1 of the expected track. The type of the special work is fabricated in the girder rail, which includes the tram with the flangeway rolled in the rail section. A mate is similar to the frog located on the side of the switch, with the equivalent to the straight stock rail of the switch. When open at the curved position, the guide wheels pass the mate on the turnout and curve in the side of manner similar to the frog guardrail. Guidance general. In addition to the consideration above criteria, inspectors must perform the following when inspecting switches. Check alignment, gauge, and surface. Examine the conditions where the switch points and stock rails. See all the bolts and nuts and cotter pins and other fastenings are placed in good condition or properly tightened. See that all the switch points are snugly against the rail. When switch is thrown, either the position request the railroad representative operate the switch. Test the loss of motion and loose connections. If applicable, examine the broad fastening, the connection of the switch points of the switch circuit controller to ensure that they are in place with the good condition. Examine the conditions. Support the spring and the power switch machines, the hand and throw switches, including automatic safety switches and the switch stand and machine fastening head block ties that must be tied to avoid any of the movement in play. Examine the switch lock and keeper. Examine the condition switch position indicator of the note any of the unnecessary obstruction of its visibility. Examine the heel block fastening of the bars in the absence of a heel block. Examine the floating of the heel of the switch point. Examine the seating of the stocking rail with the switch points to ensure the outer tread of the wheel cannot engage with the gauge side of the rail with the chair of the braces. Do not cam with these rails that affect the particular problem to travel the direction from the gauge frog to the switch of the trailing movement. The grease lines and the slight grooves running in the slight angle of the tread of the stock rail can provide inspectors with the clues about wheel rail interface. These marks can be found with the area where the wheel tread transition from the switch rail to the stock rail. When found, the inspector should closely examine the gauge side of the stock rail to make sure that the outer edge of the wheel treads are not contacting the gauge side of the stock rail. Examine the gauge plates and the switch rods. Alright, 213-137, frogs. 137A. Flange weight depth measured with the plane across the wheel bearing area of the frog on a Class 1 track must not be less than 1/3 of an inch and less than 1 1/2 inches in classes in 2 through 5 track. This traditional American Railroad Field Manual with the interchange rules to the state with the condemnable with a flight hinge weight of 1 1/2 inches above the approximate center line of the tread. The Riemann portfolio track work plans point at a flange weighted dimension provided with the design flange weighted depth of at least 1 7/8 of an inch. Therefore, amount of the clearance between the worn wheel of the high flange and the bottom of the new frog flange weight may be limited to 3/8 of an inch. Higher speeds if worn with the frog flange weight less than 1/2 inch of the wheel flange could be the bottom out in the flange weight, resulting in severe damage to the frog. Section 213-137A permits the flange weight depth of 1/38 of an inch in the Class 1 track, and such that the condition wheel is approaching condemning limits must be by contact at the bottom of the flange weight as possible to do evidence for the wheel flange weight contact on the bottom of the flange weight caused by compliant wheels. 137B. If the frog point is chipped with broken more than 1/5 of an inch down and 6 inches back, the operating speed over the frog may not be more than 10 miles an hour. If the frog point is chipped with the broken more than 5/8 of an inch down with the 6 inches back collapsible point area, the possible area after repeated wheel impact, this parameter requirement the defective may be more than 5/8 of an inch down with the original portfolio location 6 inches back toward the heel is considered. For example, the frog point that is 7/8 of an inch below the original portfolio actual frog content point, the 7/8 of an inch below at a position of 6 inches back toward the heel of the frog would be defective. For a severe condition that would not meet the criteria, such as the breakout of the frog at the point where it is only 4 inches of the length of the greater than 5/8 of an inch in and down, the inspector may consider the using defective code 213 defective code 013-137E. The condition may not be defective. The method of notifying the railroad of the condition. The inspector feels for the structural integrity of the frog is in question. Please note that statute 213 defective code 137E does not link the paragraph to this track. Safety standards may not be used on any of the advisory to the railroad. Any other possible result with a severely worn frog point, especially coupled with worn and loose guardrail, the railroad wheel may hit the point of the climb on the wrong side of the frog. With the see the figure paragraph 137 below for the information of the depressed point, the design that may influence the measurement of the worn and the broken frog point. 137C. The tread portion of the frog casting worn down with the more than 3/8 of an inch below the original contour operating speed over the frog may not be more than 10 miles an hour. The paragraph specifies the amount of the tread wear with the original contour of the casting. The original contour can be determined the variety of the way depending on the frog design. The tread of the frog considered to be any portion of the contact with the tread wheel exemption with the frog with the actual point of the position 6 inches back towards the heel with this area addressed with the statute 213-137B as shown in the following figure. Measurement of the portion tread further back than 6 inches position may be taken by placing a straight edge position transversely. The following figure shows the rail bounded magnesium frog design. Actual frog point is 3/16 inches lower than the tread portion of the frog built without magnesium insert of the frog composed of the T rails called bottom bolted ridge frog with the point of the similar familiar profile. Call the design press point with the tread with the taper up at the top of the rail profile with the direction toward the frog heel with the varying distance depending upon the different manufacturer's design size of the frog, but not less than 5 inches. Are your rail-bound magnesium fried depressed points, shaded 6-point area of tread wear measurement, tread area, the wing rail, the treaded area, the straight edge conversely spaced, adversely length of the frog and why the tread wears occur. Then it shows the side view of the point, the original contour, the point of the area 6 inches away, the tread wear, the point of the straight edge longitudinal point heel, the tread wear, the unworn area. Keep in mind that the area might be part of the ramp that depresses the point of the frog. The number 12 ramp up at the actual point of the top of the running rail profile is 1/2 frog number 1 inch, 1/2 the frog number in inches, not less than 5 inches. An alternate rail-bound magnesium solid cast frogging design includes the profile whereby the tread portion of the casting adjacent to the frog point is manufactured to place 1/8 of an inch above the top of the rail profile, while the wing wheel riser shall be following figure. The design characteristics not be considered with the measuring tread wear as discussed below. This shows the wing rail of the tread area, the riser of the tread area, the throat of the frog. So you see the straight edge of the no tread wear of the in through the frog where the tread and the wing rail. 1/8 inch riser. We're measuring tread wear. The distance from the bottom of the tread to the warm of the tread of the riser measured with the various type of the gauge should for the following leaf gauge with the different degrees of the taper, the wedge type of the tie gauge with the main to be obtained with the measurement of the taper. The measurement also frequently used to measure the tread wear. There's a wide variety of new frog design being developed with the use of an industry that may be required a different measuring technique for the tools must be given the consideration. One example, the conformable frog with the design with the conformable frog casting through the original tread of the point of the air tapered with the same angle as 1.1 to 20 ratio with the tread of the wheel to the rear impact loaded and smooth. Wheel transition, the wing transition portion of the casting, the conformal frog of the raise, the stem of the above the wrap of the ring layout of the frog, measuring the amount of the wear of the conformal requires use of special straight edge of the properly measured tread point of the flange weight depth due to the conformal design. Use of the standard straight edge of the conformal frog may result in proper wear limits and measurements. If the tread is worn more than 3/8 of an inch, the corresponding flange weighted depth may also be in the reaching critical limit of the sense of magnesium insert, but typically designed to be about 2 inches thicker at the wall, with the flange weight about 1/38 of an inch less at the bottom of the flange weight, wearing the diagonal range of the color result in structural failure of the frog. Frog requires exhibiting small spalling spitting of the tread. Usually type of the spalling is not hazardous. Measuring of the tread of the wear should not be made over the length of the worn down due to the vibration plastic flow of the metal not be able to at the bottom of the small spirals. However, the depression is sufficient size to permit the tread of the wheels to follow with the depression. Tread wear should be measured with the depression. Measure the flange weight depth, place the straight edge across the front of the area of the concern. Measure the space between the underside of the straight edge with the bottom of the flange weight at the space between the underside of the straight edge with the end of the tread. As shown in the following figures, subtract the tread value of the flange weight value up to obtain the actual flange weight depth. Alright, this shows the frog point, your tread area, your wing rail, your other wing rail, your distance from the frog, 2 inches straight edge on the bottom of the flange weight, your straight edge across the rails, 1.5 inch tread wear, frog point, 1.5 inch tread wear, wheel profile. When a railroad approaches the frog from the facing direction, the weight of the wheel is supported with the tread of the frog opposite with that point. Actual wheel reaction reaches the transition point about 6 inches back with the actual point. At this location, the weight is transferred to the frog point. 137D. Where the frogs are designed with the flange bearing with the flange weight depth may be less than that shown in Class 1 if operated with the Class 1 speed. The paragraph provides for the exemption of the item specified track with the work with the design does not conform to the minimum flange weight depth requirements prescribed in paragraph 8 of the section called the flange weight bearing frog with the technology under the consideration method of reducing the impact loads of the frog. The design is a new concept for track above the hour speed has been used extensively in light rail transit track work. There are a number of frog dimensions in the use with the thorough industry, with the most common type of the rail-bound magnesium bolts, rigid, stiff, special attributes to the spring frogs. They were covered within Statute 213-139. Conventional movable point frogs are found with the flat angle with the track crossing, slip switches. See a figure above. The type of the movement of the point frog is similar to switch because of the movable points that fit against the knuckle rail, which is like a stock rail. This shows the movable point and the knuckle rail. Conventional movable point frogs. In recent decades, new technology movable frogs have been introduced in the nation. There are two types: swing noses, left figure below, move with the wing with the right figure below. The conventional movable point frog with the switch nose frog with the virtual switches. Therefore, there are no guardrails to switch, appropriate to use the applicable elements of Statute 213-135 switches. The inspection report then counting defects in these movable point frogs. For example, the movable point does not fit the knuckle rail properly would be covered in Statute 213-135B. Each switch point will have fit its stock rail properly. Switching the switch nose frog and the movable wing frog. The movable wing rail frog type is similar to the spring frog, with both wing rails removed with remotely synchronization with the switch point that is appropriate to reuse the applicable elements of the Statute 213-139 spring rail frog with an inspection report encountering the defects like above when using any of the 139 series defective codes and necessary to include in Statute 213 defective code 133A15 turnout track cross fastening not intact. Maintain the following are the key elements considered when inspecting new technology frogs. Bolting fasteners designed with the fastening movable point frog with the concrete with the timber switch with the tie is for the considered fasteners the same manner of the cutout switch of the fasteners are discussed under the statute 213-127. This manual bolt is connected to the movable frog content components put together with the considered frog bolts must be addressed by using statute 213 defective code 133A through 12 loose and missing frog bolts. On paramount importance of the proper fit of the VE points rail against the wing rail of the movable frog. Inspectors must use the judgment to determine the point of the fits of the wing rail properly with allowed with the bits wheel of the point of the of the frog. Movement of the wing rail must be inversely affect the fit of the frog point with the ring rail. When the inspector encounters a condition of the movable frog, with the should address the inspection report. No existing codes of accessible available with the condition 213 defective code 137E with acceptable with a full description of the condition inspection report. Unlike railroad bound magnesium frog with the running surface of the most of not all movable frogs are made with a hardening rail. The inspector must be aware of this rail may contain a defect that require remedial action under statute 213-133. Symmetrical rails found some switch point frogs must be closely examined during the inspection, as this point appears to be potential weak spot where the crack break could occur. When performing an inspection, the FRA inspector should discuss any concerns about any advanced turnouts with the appropriate railroad and personnel. Inspector should consult with the regional track specialist to resolve any questions about the safety of these installations. Your general guidance. Various types of the frog was available with the specific applications include bolt rigid solid magnesium self-guarded railroad bounded magnesium spring rail movable point glass swinging nose and on rail bound magnesium frog. The normal wear pattern is the magnesium insert. An inspector, in addition with the measurement that's described in the statute safety standards, should see that the frog is supported through on a well-tamed sound ties. The requirements is the flange weighted depth of the paragraph A, with the requirements of the tread, whereas paragraph C also apply to the crossing frog. Since the design flange weighted depth is 1 7/8 of an inch, safety considers the same. The excessive wear of the tread portion could result with the wheel flange striking the bottom of the flange weight, causing structural damage to the frog. Inspectors must evaluate the cracks and breaks of the frog castings, and rail defects in the non-running portion of the wing rail in terms of the potential effect of the safe passage of the rolling stock, in particular when making the evaluation. The inspection should determine if there is a loss of intermittent loss of the wheel guidance due to the loss of functional integrity. The inspector should note that they should not consider cracks, breaks of the magnesium foam casting that do not affect the safe passage of rolling stock with defective condition. If here are cracks or serious cracks that creates the condition of the work where breaking of the piece of the casting imminent with the use of 213 defective code 137E, should consider the cracks of the wear developing loss of the functional integrity should be addressed and using 213 defective code 137B or 137C, which cover the worn frog points and castings. Rail defects on non-running portion of the wing rail should be addressed by using 213 defective code 137E. 213-139 spring rail frog points. Spring rail frogs. 139A, outer edge of the wheel tread should not contact the gauge of the side of the wing rail. The inspectors must closely examine every spring rail frog encountered during any inspection. When the spring rail frog has successfully used the many areas, the unique of the design requires special maintenance to avoid a derail and hazard to the trailing point with the tray movements on the main track. The spring wing rail is higher than the top of the running surface of the frog. Transition area of the wheel during the trail move may push the spring wing rail open, causing the rail roll out of the roll out or wide gauge. Hollow or false flange wheels are more prone to cause this occurrence. This shows the spring rail hold down housing, hold down home, point of danger of trailing movement in the tread and the wing rail with higher than the frog point. At the beginning of the sign of the outer edge of the wheel tread, contact appeared with the gauge corner on the wing behind the point of the frog with the transition point similar to the shock rail and switch to the point of configuration, while the spring frog with the relief of the groove of the bolt went into the frog. For the purpose, the inspector must accurately be aware of the same sign of the gauge side of the spring wing rail. By striking out by the outer edge of the wheel tread with the wheel gauge, from the must be confused by the command channeling of the spring wing rail for the incorporated with the time of the manufacturer accommodated wheel tread transition. Vertical deflection of the toe of the frog is 213-139B, and the hold down of the housing clearance for the 213-139E must be assessed when the gauge face wheels contact with the reserve and if the toe is not solidly tampered successfully. Horns housing clearance existing. The wing rail may vertically motion while the wheels are operating with the point of the rail into the trailing movement and forces of the wing rail will cause the wing rail to move laterally, allowing the wheel to drop into at the throat of the frog. Alright, let's start off with 139B. The toe of each of the wing rails should be solidly taped and fully tightly bolted. Guidance. The toe of each of the spring rail frog must be solidly supported with the proper hold down with the housing clearance must be maintained to avoid excessive vertical movement of the wing rail. The combination of the two conditions cause the outer edge of the wheel tread contact with the first sense the occurring will gouge with the gauge for the corner of the wing rail behind the point of the frog with the gauging must be confused with the channel with the spring wing rail that is incorporated at the time of the manufacture commented with the wheel transition if the toe is not solidly tamped with the excessive horn of the housing clearance because if the wing rail has vertical motion with the operating with the point of the rail trailing point of the movement and the force of the wing rail will cause the wing rail to move laterally allowing the wheels to drop at the throat of the frog. 139C. Each of the frog with the bolt hole defective of the head wedge separation shall be replaced. The bolt defective of the head wedge separation of the spring frog with any of the dimensions constitute the defective paragraph does not prescribe the corrective action other than replacement. 139D. Each of the springs shall have the compression sufficient to hold the wing rail against the point of the rail. The guidance intent with the regulations ensure the spring holds the wing rail against the point of the rail. Typically, the wing rail is up against the point of the indication that the spring is holding as intended, but the inspector finds the wing is not against the point of he or she would determine the root of the condition component, such as the loose bolt may be obstruction of the closure. Statute 213-133A12, which should be cited without proper anchor to the horn, may bind or hold down the housing defective. Statute 213-133B should be cited with class 3 through 5. Thereby suspicion there be sufficient compression, but the spring of the railroad representative should be determined in compliance. 139E. The clearance between the handhold housing with the horn shall not be more than 1/4 inch. Guidance, since the spring rail is movable apart with the spring frog cannot be fastened down with the holding down the hose with the horn assembly prevents the wing rail from moving up the hang higher to the top of the tread with the transition point. The following figure illustrates the proper method to determine if there is excessive space between the hold down housing and the horn. Alright, general guidance. Due to the unique design character of spring frog with the turnout, the type of the typical appliance with the required special consideration regarding the guardrails on the main track with the side of the turnout when a train is not a springing, the frog is made to design operating on an unbroken path on an extra length of the guardrail, assuring the proper path of the wheel set. The guardrail shall be sufficient to the length of the cover of the design hinge length to keep the wheels off the spring wing of the rail from the point where the rail is hinged from the frog of the throat is finally actual frog of the point. While track safety standards do not address the design concept, inspectors should be aware of the attribute of the spring frog with the guardrail with sufficient length to cover the design hinge of the length of lateral wheel force can cause significant problems specifically with the guardrail. Any of the frog elements to quickly deteriorate the extreme circumstances of the wing rail can open while the trains are moving other than the main track side, which can result in an unprotected wide gauge. Inspectors should note that their inspection report with any guardrail on a spring frog that is not properly lengthened installed with the improper installation. Another special consideration regarding with the spring frog is the longitudinal relationship between the spring of the wing rail and the frog point. The turnout with the insufficient rail anchored to the restraint with the longitudinal movement of the wing rail may not function properly. Evidence of the longitudinal movement occurring with the may gap between the wing rail and the frog of the point. Inspectors are reminded to refer to Statute 213-133B, which requires the Class 3 and 5 track to be equipped with a sufficient rail anchor to restrict the longitudinal rail movement. The longitudinal movement is observed because of the insufficient anchors of Class 1 and 2 track. Inspectors are encouraged to note the condition of the informed railroad. Spring frogs are manufactured with a steel base plate with the attachment of the base plate over the clip of the plates, which are placed along with the fixed side of the frog with the clip plates, which are shaped into a right angle attached with the base plate with the bolts and welded poles. Frog bolts are placed through the body of the frog through the vertical portion of the clip plates and holds the body of the frog with the clip plate assembly. There are no gauge holding fasteners along the movable side of the frog as they would be interfere with the spring wall rail, and therefore it can be seen that the frog bolts and clip plate assembly acting together maintain alignment with the spring frog. Care should be taken to ensure that the frog bolts or clip plate bolts are in place and tight in the statute 213 defective code 133A12. They'll check clip plates to see if the welds are cracked and broken. The clip chip plates crack breaks at the corner where the plate bends from a horizontal to vertical where the crack breaks, and the clip plates affect the fastening of the frog to base plate, and they use the defective code 213 code 133A15 insufficient fasteners. In recent years, railroads have an augmented the design of spring frog installation by the application of improved stops and limited amount of the movement of the spring rail. Additionally, some of the frogs have been retrofitted with weld stops. Most stops are designed to allow the wing to open no more than 1 7/8 inch to 2 1/4 inch. When the stops are properly installed, the risk of the trailing point of the derailments is reduced. Alright, when spring frogs are equipped with the improved feature such as relief groove the stop, the inspector should evaluate the condition of the components in order to ascertain that the improved features are in function as intended. When the spring frog defective found, the defective conditions must be repaired as soon as possible. Combination of the defects are especially hazardous. The railroad must protect the movement of other frogs at the speed restriction until the defects are repaired. Spring frog defects are considered non-class specific defects, statute 21399. Therefore, the inspector must consider circumstances involved evaluating the remedial action taken by the railroad. When spring frog defects are found, the inspector should consider all of the spring frog defects or serious defects that may be repaired as soon as possible. In most circumstances, when the evident outer edge of the wheels are in contact with the gauge side of the wing rail, or the combination of the spring frog defects the inspector would expect the railroad would implement a speed restriction. Some spring frogs are required to retard to reduce the impact of the wing of the point wing close to each of the passing of the wheel diverging route. The retarders may hang and cause the wing to remain open. Though track safety standards do not address the design concept, inspectors should still be aware of the attributes of the spring frog because it could lead to further degradation of the frog components. 213-144 self-guarded frog. The raised guard with the self-guarded frog may not be worn more than 3/8 of an inch. With examining self-guards, observe the condition of the frog point, whether the evidence of the wear caused with the wheel flange contact with the frog point. Take the measurement to determine the compliance with the section. Determine whether the amount of the wear the raised guard measuring the thickness of its portion where there is wear. Compare the measurement of the portion where there is no wear. The difference between these two equivalent is the two amount wear. Alright, your unworn side with 2 inches to worn side 1.5 inches, 1.5 inch wear. If the repairs are made 141B, if the repairs are made to self-guarded frog without removing the surface of the guard, the force may be restored before rebuilding the point. Guys, during the repair of self-guarded frog, the imperative of the raised guard faith is restored before the actual frog point. The precaution necessary due to the potential for the wheel flange striking the frog point. Self-guarded frogs are designed to use the low track speed. They use the track where speeds exceed 20 miles an hour can result in excessive lateral forces such as the wheels kicking or, in extreme cases, of the wheels climbing up the raised guard. The track safety standards does not prohibit the use of the self-guarded frogs in any class of the track. However, the inspectors are encouraged to inform the railroad of potential problems that may occur with the self-guarded frog and found in track where speeds of 20 miles an hour. Alright, class 1, your guard check is 4 foot 6 and 1/8 inches. Guard face is 4 and 5 1/4 inches. Class 2 track is 4 and 6 1/4 inches. Guard face check is 4 and 5/8 inch. Class 3 and 4 track, the guard check gauge is 4 foot 6 3/8 inch, and the guard face gauge is 4 foot 5 and 1/8 inch. Class 5 track 4 foot 6.5 inches and 4 foot 5 inches as a guard face gauge. A guardrail is in stereo parallel to running a rail opposite with the frog when the flange of the railway to hold the wheels equipment with the proper alignment with the passing of the frog. A guardrail must maintain the proper relative position of the frog in order to accomplish the critical intended safety function. Inspectors should examine the guardrail carefully to see whether they are adequately fastened when the measuring guardrail gauge fully consider all the movement of the guardrail frog and under the traffic conditions. This section clearly specifies the allowing tail length of the guard check with the guard face gauge for the various classes of the track. Measuring guard face check gauge is important to conserve the path of the wheel through the frog because of the function of the guardrail to keep the wheel flange from striking the actual frog point. As a reference standard check gauge of the rail with wheel seat is approximately 54.5 inches. See the following figure is approximately designed check of the gauge is followed with a track safety gauge standards. Minimum guard check gauge is less than the wheel check gauge is lower than class of the track. Condition of the actual frog point is relation to the path of the wheel of the frog is good indicator of effective of the guardrail. Alright, your wheel check is 4 foot 6 inches and a half, or 54.5 inches from the frog in its tread is frog on the flange and frog on the flange way at 1/8 of an inch off the point through the guardrail flange way train check at 4 foot 6 and 5/8 of an inch, or 54 and 5/8 of an inch. The critical error with the guard check, it must be measured by the actual point of the frog. The inspector must also consider the unusual wear that may exist with the actual frog point and the position of the track gauge by other measuring devices accordingly. The measuring guard check gauge the dynamic lateral movement of the guardrail of the frog should be considered in the case of the frogment moving the lateral under train movement and floating. It's important consideration more restrictive measurement, specifically if the measuring of the guard face check of the turnout whether the gauge can be moved toward the track of the being measured due to the train movement on the other track of the dynamic frog position would be considered see figure below. You have your main track and the track number 2 with the guard face check. Check the gauges between the turnout number 1 track and the resulting shove of the frog, force of the shove of the frog. In severe cases where the frog is severe floating, moving, lateral, underload, whether there is accompanying condition to deteriorate cross ties, infected fasteners, FRA inspector should decide the defective recommended simple billing for the accompanying condition of the 213-109 cross ties and the rail 213-127 rail fasteners. Face gauge is the dimension of the brake becomes critical of the distance between the two opening guardrails. The guardrail frog wing rail becomes larger of the distance between the back of the wheel set. The wheels occur with an improper position of the condition such as a severe alignment defect. Normally, face gauge would measure with the vicinity of the check gauge. However, the inspector should consider the measuring face gauge as a point of the special track work, whether they may be indicated with the wheels or being pinched. For a general reference, the following illustrated approximate design face gauges. Your wheel face gauge is 53 1/4 inch, and your track face gauge is 52 3/4 inch on the flangeway guardrail for the frog treadwell flangeway 1/8 inch output. Alright, broken guardrails occur interference infrequently since they do not support with the vertical wheel loads the bashing the value. When the crack of the brake of the guardrail, inspector should be aware of the crack of the brake is existing but do not affect the ability of the guardrail to function and intended with the integrity of the guardrail to portray. Affected inspector will decide the defecting using 213 defect code 143A3 with the crack or broken guardrail. There are many different types of design for a guardrail design. Some of the quad guardrail plates are recessed to the seat of the running rail while the others are flat. Some of the guardrail plates are punched out spike holes and slots. Others are not. Other guardrails are bolted with the running rail. On some of the rails, normal practice not to be spiked with the gauge side of the running rail through the guardrail area. The guard plates do not have the hole punched for the purpose. The FRA has not recorded safety problems they have developed as a result of non-spiking from the running rail for the guardrail area. The encountering problem whether the running rail has moved laterally to create an unsafe condition. The inspector should insufficient passengers defect goes 213-127. The inspector should discuss the unique situation with the regional track specialist. While not in a requirement of the track safety standard, the guardrails have the straight portion of the guard's wheels through the area with the throat. The actual frog point of the inspector is made the guardrail where the straight portion of the design encompasses the area. The inspector should bring this point attention for the railroad. The following figure illustrate the proper measurement of the point to determine the check face gauge and compliance with the shows the proper longitudinal relationship between the guardrail and the frog point. Alright, this shows the critical guarded area from the throat to the frog. The check and the face gauge of the frog. Alright, your face is back-to-back gauge, and your check gauge is from the center, from the outer part of the throat. The inner part, and then get face back-to-back gauges. Subpart E: track and appliances and track-related devices.